I have a tendency to speak too fast, and that annoys people who are native English speakers and is probably exceptionally annoying to non-native English speakers, so I will try to talk slower, and if I talk too fast, you can wave at me, maybe just with one finger, and tell me to slow down. Thank you, Seba. Today, I want to talk about some tools that we've been developing and talk about how you can use source code and some of the technologies that we've been developing along with OWASP, ZAP, and potentially other tools to get benefits when you're doing web application penetration tests or web application assessments. So agenda-wise, I'll talk just a little bit about my background, talk about why there's value in using source code when you're doing application assessments. And then I'm going to talk about this technology we've developed called hybrid analysis mapping that we've developed in conjunction or funded by the United States Department of Homeland Security. And then I'm going to show an example of the tools that we've developed and released for this. And we'll look at how it can be used to do three different things. The first is to do attack surface enumeration. So in using the source code of a web application to highlight all of the potential attack points in the application. Use it also potentially to identify backdoors that have been intentionally added to applications. And then also talk about how it can be used to identify potential configuration problems with certain web frameworks. And then we'll have some time for questions at the end, or if you have a question along the way, please feel free to just raise your hand and I'll do my best to answer them. That's a picture of me. Just a little bit about my background. I'm a software developer by background, originally in the mid to late 1990s, doing a lot of work with early server-side Java stuff, then in the early 2000s doing a lot of early ASP.NET work. But really what I've spent the majority of my time in the last probably 10 years of my career is looking at how software developers and the software that they build impacts the security of organizations. And so I have a background as a software developer who has come into the security space instead of being someone from a more traditional penetration testing or network security background that has come into security, and that colors my views on the matter a little bit. So, why use source code? And that's an interesting thing. That's a conversation that we have in interacting with organizations from time to time, where they say, if your pen testers are so clever, why do you want access to source code, right? Are your people not smart enough? We get this a lot with mobile application assessments of, if your testers are so good, why do we also have to give you the source code? And the answer really comes down to a question of goals. If you're doing testing of an application, in certain cases, it makes sense to attack from a blind standpoint. We've used that approach in the past where certain security executives want to make a point. Where they want to be able to go to their executives and say, here's the very limited set of information that we gave these people, and here's what they were able to do. And so from a politics standpoint, occasionally there's value in being able to say, when given nothing, these testers were able to find so much stuff. But the much more common or more frequent occurrence is that the purpose of testing is to learn more about the security state of the application. And so what you really want is the most amount of security insight for whatever budget you have. So everyone here presumably works in an organization where you have some sort of a budget, either of dollars or euros or manpower, right? Does anyone here work in an organization where you have no budget, unlimited budget? Are those organizations hiring? Because that would be a fun job. Right, but most organizations, you have some sort of limitations. It's either a monetary amount. If you're going to outside testers, it's the time for your internal testers. And so really, if you want to get the maximum amount of security insight for that investment, it makes a lot of sense to provide source code to the testers because there are often things that are easier to test from static analysis, reading source code or doing static analysis in an automated way versus testing a live system. And so, that's really, we encounter, as I said, a number of arguments. Aren't your testers smart enough? Like, my testers would love to spend time reverse engineering your iPhone binary, right? Or decompiling your Android binary or doing whatever. But the question is, is that where your time or your investment is best made, right? And so, really it's a question of goals, and if you want to have the maximum amount of security insight, it typically makes sense to do or to provide both source code as well as a running application so that you can switch between statically testing or looking at source code and dynamically testing, looking at a running application. And so what I'm going to talk about is some technologies that we've developed and how we've been able to use those to increase the quality of the application penetration testing that we're doing while keeping the time low, and also how we're able to increase the thoroughness of the testing that we're doing. And again, everything that I'm talking about here you can download off of GitHub, and I've got the slides will obviously posted, and I've got links to downloads and whatnot. So this is something where if this is something you're interested in, this is obviously something that you can do. We have a plugin for Zap as well as for Burp, and we're working on other plugins. Again, love to hear feedback from folks if they find these techniques useful. The technology that we're going to be talking about is called hybrid analysis mapping. And it's the original goal of this was, how do we merge the results of static testing and dynamic testing? So if I have a set of static testing results from a tool like a Fortify or a Checkmarks, and if I have a set of dynamic testing results from a tool like a Web Inspector, an AppScan, or a Zap, how can I stitch those together and get a unified view into the security testing results that I've found? And as I'll talk about, and this again may be of some interest to folks over here. We've worked with the U.S. Department of Homeland Security. They funded a lot of this, and again, we've made it available, open source, as a part of that contract. And so we're currently in phase 2. We've been working on this research for about 3 years in total, and this is with the U.S. Department of Homeland Security Science and Technology Directorate under a SBIR grant or contract. And the goal of these is to identify new technologies for United States federal customers. What are different departments in the U.S. federal government interested in, and how can they provide some funding to get private firms to develop those technologies? Again, what we've built is hybrid analysis mapping. We've included it with our ThreadFix Community Edition server side, but we've also made it available in a couple of client-side tools, and that's what we're going to be talking about today. And I also, one thing that probably makes sense to say is I don't speak officially for US DHS. I'm not employed by them. This is a contract where they've provided funding, but I don't speak officially for them. I'm speaking for myself today. This should not be seen as an endorsement, as in I guess they provided the money for it. So, as I said, our initial goal in creating this technology was to figure out, can we take, and the scope of our initial testing, just for clarity, was if we have results from a static test with SCA, a dynamic test with AppScan, can we stitch those together and identify where there are overlapping vulnerabilities that were identified? We just found in a number of organizations that we'd worked with, they deployed those two tools in just the way that the acquisitions had happened. One technology ended up at HP, one technology ended up at IBM, but these organizations had a need to make these tools operate better together. And from that we found we were able to do this as well as to do some other things that I think are interesting. And so to provide a little bit of background, is everyone here familiar with dynamic application security testing, or DAST? That sounds good. Just as a little bit of background, that's the testing of a running application. And so we're going to look at a running system. We're going to exercise that system and look for patterns that indicate that there may be vulnerabilities. And the typical process that you use for this is you spider the application, much like Google would spider the internet to index things. You're going to crawl an application, start at the home page, look at the HTML, look at the JavaScript, find links to external pages, go crawl those, and look for all the forms that can be submitted, all the parameters that can be passed in, cookies that are in use, things of that nature. And obviously for testing web applications that have a login requirement, you also have to train the tool to log in and to know when it has a valid session so that you can see, so you get better coverage of the application. Once you've identified that attack surface of all the pages you can post to, all the parameters that can be passed in, then you fuzz that, send in various payloads, look at the responses that come back, and look for the presence of vulnerabilities. So if I submit to an application a SQL control character like an apostrophe, and I get back a JDBC error message, I look at that and say that request and response pattern seems to indicate the presence of a SQL injection vulnerability. And for our purposes, what a finding looks like is the vulnerability type, the relative URL or the position in the application, as well as for certain types of vulnerabilities, that injection point. So if I have a misconfiguration where I have directory indexing turned on, for situations like that, I don't need an entry point. I just need to know if I go to the /reports directory, I'm going to get a listing of all the files in the directory, and that's probably not the way you want your server configured. But for a SQL injection, I need to be able to say, well, for the login.jsp page, if I pass in a username parameter, it appears that we have a reflected cross-site scripting, or whatever it might be, but we need to know that parameter or that injection point. When we talk about static application security testing, that's looking at an application at rest. So looking at the source code of an application or the binary of an application, doing some analysis on that, data flow analysis, control flow analysis, and through that analysis, looking for patterns in the code or in the binary that indicate potential presence of vulnerabilities. And so I think you can kind of see here where we have anything passed in via a parameter under the control of an attacker, right? So we see that we get tainted data from that get parameter call. That gets assigned into the username variable, so then we can consider that username variable to be tainted. That username variable gets combined with some other text and assigned to the SQL variable. So that variable is then tainted. And that tainted variable of SQL gets passed into the sensitive function of execute. And so here we're able to start with this username parameter being passed in. We do the data flow taint analysis, find it passed to a SQL sensitive function, and in that way we've identified here we think that this is a SQL injection vulnerability. So we've essentially found two of the same type of vulnerabilities, or potentially the same vulnerability, but we've used different types of analysis in order to find that. And so our original goal was, how can we take these very different types of analysis and stitch the results of those together so that I can do more testing, but have a consolidated view into those tools. And where I have overlap, that gives me really valuable information that I can use to potentially pass on to developers to say, here's the request that came in, here's the data or control flow through the application, and here's the response that came back, right? And so as a security analyst going to a developer, that makes a stronger case potentially that yes, this is a true positive vulnerability, and here's the information you need in order to remediate this more quickly. You know where the stuff is in the code, you can see the behavior, and seeing all of that data together makes it easier for a developer to go in and hopefully successfully remediate. Any questions about that so far? Good. So to do this, we needed to solve make three different decisions or solve three problems. The first was to standardize on some sort of vulnerability naming or vulnerability taxonomy, and we ended up standardizing on the MITRE CWE, or Common Weakness Enumeration. Each vendor has their own. The HPE folks or the Fortify folks have their 7 pernicious kingdoms. I'm a native English speaker, and I don't really use the word pernicious very often. So that's I've done training actually for non-native speakers in Fortify, and always get to that section of the slides. And I'm like, pernicious. But we relied on the MITRE CWE, which certainly has issues, but has actually worked very well for our purposes. That's probably the best taxonomy out there. The joke, I think, is democracy is the worst form of government except for all of the other options. The MITRE CWE is the worst vulnerability taxonomy except for all the other options. And so that's actually proved to be a pretty valuable or a good decision that we made, rather than creating our own taxonomy that would just be challenging to maintain and keep tracking forward over time. We also, to solve this problem, need to match static and dynamic locations. And this will become important to some of the stuff we talk about later, where I need to know when a request comes into a particular URL, what code is actually going to get stitched up to that URL. So when I take this code, compile it to a binary or whatever we do, when this code ends up in the running application, where on the application's attack surface is that code going, or how can you reach out and touch and execute that code? And then we also had to determine, in cases where parameters were being passed in, how do we identify where that parameter enters the application. So when I know what a request looks like to a web application, I have the URL and the parameter, how do I know what code is responsible for that behavior in the application? So those are the problems that we set out to solve. So given the source code, which we can pull from Git or Subversion, or you can pass it in directly, we detect the framework type and the language. And so we go in and look and identify, this looks like it's an application written using Java, and it appears to be using the Struts framework, or it appears to be using the Spring framework, or Ruby on Rails, or whatever it might be. And so there's a set of languages and frameworks that we support. Some of the static analysis tools provide some additional meta information. If that's available, we use it, but it's not required. And so from this, we build what we call as an endpoint database. So by knowing what the language and the framework are, that lets us enumerate all of the URLs that that application should respond to, and as well as all the parameters or cookies or other entry points there might be to that application. And we build a database of all of those and keep track of the source code entry point that is responsible for each of those pieces of behavior. And so this is not necessarily, at this point, we're just figuring out for this application what are all the behaviors that we can potentially see, and how, what code is responsible for those. With no thinking about security at this point. We're just trying to understand, how do we expect this application to behave when this source code or binary code starts to be a running application. From that let us do the merging of the static to the dynamic results, because what we can do is look and say, for example, I have a dynamic result. I have a reflected cross-site scripting vulnerability in the page login.js, or in the URL login.jsp for the username parameter. That's what that dynamic scanner told us, that it found a vulnerability. Then we can query the endpoint database, and that's going to say, well, this is a Java and Spring application. That particular parameter enters the application for that URL at com.whatever.whatever.logincontroller.java at line 62, let's say. So then I can go and look at my set of static findings, and if I find a reflected cross-site scripting vulnerability at that particular class and for that particular entry point, I can match those up and say, I believe that this is two pieces of evidence I have about one vulnerability, as opposed to being two individual findings that need to be triaged separately. So that's basically what we, how we set about solving that problem. And what we found was, again, from a research standpoint, we feel like it produced a successful result, because we're able, typically to be able to identify these situations. But we got to talking inside of our organization and said, what other stuff can we do? Can we do any other queries, or from this data structure that we've built, are there other queries that we can do, other operations that we could perform that would potentially be valuable? And so one thing that we looked at doing was saying, what if I did, the SQL equivalent of a select star on that database, right? What if I said to this endpoint database, give me all of the endpoints you have in that database? That's interesting, because that tells us, again, all the URLs that application might be willing to respond to. What we also found, and we'll talk about this less today, but what we also found is, even if we only have dynamic results, but we've built this data structure, we can map things back to entry point lines of code. So we can potentially, when we have source code and a dynamic test run with like a zap, we can say, okay, I've got this reflected cross-site scripting vulnerability for this URL. We can go to the source code in the developer's IDE and put a marker. And that's not as good as you would have. Most of the static tools have really nice IDE plugins where you can go and step through the entire data and control flow. That would be better. But if you don't have static results, if you only have dynamic results, but you've also built this endpoint database, that's a transform that you can do. And so I won't talk about that as much today, but that's one of the things we also did, is provided plugins for Eclipse and IntelliJ, and I think we've got one for Visual Studio now. That will put markers at the entry point, again, with the hope being, can we get developers in a position to fix these lines of code more quickly than they would have otherwise. What we did, and what we'll talk more about today, is created plugins for a number of different dynamic scanners, so that we can take these, we can take this endpoint data and use it to precede those scans. And so we've got plugins right now for OWASP Zap. We've got plugins for OWASP, or for Burp. And we also have a plugin, although I don't think it's been released yet. It should be shortly for AppScan, IBM Rational AppScan. And today we'll talk about the OWASP Zap plugin, just because Zap is pretty awesome, and because this is an OWASP conference, and because that's a fully, again, the plugins are free, but the Zap is also free, so you can take this home and take a look at this stuff. And so that was the question that we had, is like, hey, if we have this attack surface data, what can we do with that? And what that lets us do is some really interesting stuff, because we can identify situations, or we can identify things that you wouldn't see during the normal course of the crawl. As these dynamic scanning tools try to crawl the application to guess or to determine the attack surface, there are a number of scenarios that you can run into where where the scanner's not going to see everything. And especially when you're looking at situations, if you're doing testing of a mobile application and looking at the REST services of the back end, it can be really challenging to get a full picture of what are all the different methods that this API is exposing. Same thing if you have like single-page web applications that are talking mostly over REST endpoints. The different scanners have varying levels of quality or capability in determining this. Just again, some quick final thoughts about this. In my humble and unbiased opinion, I think this is a great use of that program with the DHS folks, because we figured out what we originally wanted to figure out, but we're also able to do some additional interesting stuff. So to get the plugins, there's a couple different ways. I've got some links. I've got links. I will add links to these slides. I think add links to slides. Where you can download these plugins and a command line tool directly, or you can just pull, there we go, and you can just pull the code off of GitHub and pull it out or running. Like when you build the ThreadFix server, there's a page that you can go to on the ThreadFix server and download the plugins. So like during the build process, it builds the plugins and then stuffs them in the WAR file that runs the server, so that you can download them directly from there. And I can show you what that looks like. There we go. And so it's just a page here where you can go to download tools, and then it has all these various tools in there. So you can pull those and you get access to those. Again, you install it just like you would any other Zap plugin. There's a .zap file. We've got instructions on the wiki page, and you basically import it. And like I said, we also have similar plugins for Burp Suite, and we've got one for AppScan that should be available soon. And all the plugins essentially work do the same, have the same basic capabilities. So I want to talk about three different things that we've found that we can do with this technology. And the first is attack surface enumeration. Second is identifying potential backdoors, and also helping you to do some auditing of configuration settings. And the idea here is, and kind of philosophically the way I look at it, anything that can be automated, I love automation, right? If the more automation you can include, that is going to do nothing but help. Again, I think everybody here probably knows, if you look at the count of developers versus the count of app security people are horribly outnumbered. Like the Battle of Thermopylae movie 300 outnumbered, right? It's just, so you have to have as much, wherever you have opportunities to use automation, that is tremendously helpful. There are also things that have to be done manually. And so in cases like that, we want to use automation to help support that, those manual activities. And so, again, we'll talk about a combination of things that are either fully automated or situations where where you can become more efficient by using these types of things. So for the attack surface enumeration, what we want to do is take this data structure we've developed and enumerate all of the URLs that the application will respond to, right? We want to know every place that someone can reach out and touch this application. And that starts by knowing all of the URLs that application will respond to. We also want to know what are the parameters that we can pass in that will potentially change the behavior of the application. So again, we want to know if a bad guy or if an adversary is looking at the application, what is everything that they could possibly go in and touch? Because ideally, that's going to be the scope of what we do security testing for. If we know the attack surface, then we can at least have some level of confidence in the level of coverage that we have from our testing. So why is this a problem? Again, all these dynamic scanners, they're built to crawl. Give it the first page, it finds the second. Some of them are doing better things with JavaScript proxying, watching traffic in the background. The challenge is that applications rarely work the way that you want them to, and this is especially the case as developers get more clever over time. You find things, hidden landing pages that link into the application, but where the main navigation never links out to them. We find a lot of situations where there's multi-step processes, like a shopping cart checkout, where the automation doesn't necessarily successfully crawl. They get to the first step in the process, submit some junk data, but it doesn't take them to the second step of the process. Right? Or if there are different states that the web application could be in that will cause it to redirect it to different pages, or to show evidence of certain parameters that it will listen to. And we'll also talk about sometimes there's debug functionality and things of that nature. We'll talk a little bit more about that later. And this is also, we found this to be very useful if you are looking at applications that make extensive use of REST APIs. And this is most common, these days it's most common, I think, for mobile applications that are calling back into some sort of web service. It can also be valuable for single-page web applications and things like that. And so, these are situations where the current set of dynamic testing tools are not very good necessarily at that crawling process. And so you run the risk then of having false negatives. And so if you're looking at testing, you have two bad situations that could come up. You have false positives, which are a serious problem with both dynamic and static testing tools. And a false positive occurs where the tool flags a vulnerability, but that vulnerability is not actually a true vulnerability. This is looking at the flip side of that problem, which is false negatives, which are there are vulnerabilities in the application, but our testing, for whatever reason, didn't identify those vulnerabilities. And so what we're trying to do here is make sure that we're penetration testing all of the application, that we know all of the endpoints that an attacker might find and try to exploit, because we want to see that coverage of the application. We want to see strong coverage of the application so that we feel like the automated testing that we're doing is covering sufficient ground. So we've taken this technology and stuffed it into a command line client, and so let's go. Okay. So we can run this against threadfix. It complains about the Git stuff. And so what we see here is, so basically what this did is this went and looked at, in this case, the threadfix source code, detected this is a Java and Spring application, went through and identified all of the classes that had controller annotations and said, because I understand how the Spring framework works, I know that these controller classes are going to take different methods and attach those to URLs to execute. It also goes through and parses for all of the model annotations and builds the object graph of those different model objects in memory. And we'll talk more about that later. But in doing that, because it understands the framework, it can enumerate, again, here are all of the URLs that this application will respond to, as well as all the parameters that can be passed in to that. And so what we see here is, and like at the tail end, we're looking at a lot of the REST API, where we see we can post to REST, WAFs. It knows that it knows when certain parameters are ID parameters, or when certain paths, parts of a path are ID parameters. So it identified that there. and also knows that you can pass in to this method a file and a WAF ID. Parsing parameters out like that is also helpful because a lot of times the dynamic scanners, when they do dynamic scanning, will over-report certain vulnerabilities. So if you have a RESTful style of URL creation, like the pet clinic is a good example, the Java pet clinic, where it'll say, /pet/1/ something, /pet/2/pet/3. Well, if you have a SQL injection vulnerability, the crawler or the fuzzer is going to find that a number of times, and it's going to over-report that. When in actuality, what we know, because we've analyzed the source code, is all of those requests, pet/1, pet/2, pet/3, all of those will go and touch the same source code entry point. So if we actually know that, we can actually clean up the dynamic scan results and collapse those down and say, I know that this hits the same code, and therefore these X number of dynamic findings that we found, we can roll that up into into one finding. But it also lets us know, again, all the parameters that can be passed in. And so in this case, this can be really helpful because this is enumerating for us all of the REST APIs. And HTML and the page structure of a kind of more traditional web application, crawlers are okay at figuring that stuff out, but they're really bad at identifying REST endpoints. And so what this lets us know here is, hey, this thing has a whole REST API, and here is the set of methods and the set of parameters that we'll need to test if we want to feel like we've got sufficient coverage. This is also great at identifying like old versions of APIs and things like that, forgotten source code that the development team might not be maintaining, might not be actively testing, but that will still be exposed in a build. And so it's I've at least found a lot of value in being able to run a quick dump of the source code and to enumerate this type of stuff, because from a manual standpoint, this shows you a lot of stuff that you might not otherwise know, and it can identify potentially interesting things that you can go and test. And from an automation standpoint, when we plug this into something like Zap, what we've done with the plugin is we can then go in and say, I want to import our endpoints from the source code. This is an example of the budget store. We want to use that source code location. That corresponds to that dynamic location. What we see over here is we've pre-seeded the spidering process with a lot of information that it would not have had otherwise. And so we are finding things like this page, admin.jsp, that you wouldn't find if you just did an unauthenticated crawl. You wouldn't necessarily find that admin.jsp page because there would never be a link in the HTML to that page. But because we have foreknowledge of the application's attack surface, we can precede it and therefore test that. And if I'm manually testing, I'm probably going to go and see if I can access admin.jsp if I haven't logged in. That's not an unheard of mistake for people to make. And it also lets us know that that page is going to be subject to the dynamic. If we do an automated scan of this, then that page will be included in the scope of the fuzzing that is being performed. Any questions about that? And so again, this is going to identify if you have multi-step workflows, if you have landing pages, all these things that a traditional scanner in its spidering process might not find. That is going to be available both for, as you're manually testing and creating your checklist of things that you want to take a look at, but also making sure that that is in scope for the dynamic testing or the dynamic automated fuzzing that's being done. Again, the goal being here to hopefully reduce or eliminate false positives, and that's not the thing. So right now it's Java with. Oh, sorry, repeating the question, right. So what technologies are supported right now? There's Java with support for JSP, Spring, and struts. There's C# for ASP.NET Web Forms and ASP.NET MVC. There's Ruby with Ruby on Rails, and we have some initial support for PHP. The PHP support is supports very well a situation where your PHP file layout matches very closely to your URL layout. But if you're using like WordPress or another PHP framework, then it's going to be confused by that. And then I think we're looking to add Python, Django, and some JavaScript, server-side JavaScript support are kind of the things that we're looking at. And the nice thing about this is, if you look at our Spring support, it's maybe 1,000 or 2,000 lines of code, which is not no code, but is also like to add support for new languages and frameworks, especially given the existing ones. You can kind of incrementally build up a more and more capable endpoint database generator. So if you have a custom framework or if something's not supported, it's not unreasonable to think that somebody might sit down and put together a parser to start getting some of that insight. So, yes. You're asking about Android applications? Right, so right now this is only working with web applications. We're trying to work on we're hoping to land a contract soon to extend that to also look at mobile applications and potentially other types of applications. Because I think there are I think there's value in being able to enumerate, to look at an Android application or an iOS application and say, from an attack surface standpoint, this thing uses these two SQLite databases and this thing, and these files over here, as well as making these outbound network calls. And so that's kind of the direction that we're looking to go with it in the future. Excellent. So what you can also do is potentially identify, like as you look at these things, what you can potentially do is identify suspicious parameters that may be an indicator of some sort of a backdoor. And a great example here, if you look at the Budget store, is there's a number of situations where you can pass in parameters called debug. Again, that's probably something you're never going to see during the HTML crawl, but it's very interesting to see that that exists. I did some work on a cold fusion application a number of years ago where if you passed a parameter named D in, whatever value you had for the parameter D, let's say I passed in D equals 1,000, it would go and find order 1,000 and delete it. Sure, why not, right? And this was most likely a function that a developer had put into the code as a convenience thing for them so that they didn't have to log into the admin screen as they were doing development. But because this is cold fusion, that got cut and pasted into every page in the application, because why not? And in addition to that, that also then got deployed to production. And so, I wouldn't think, as a blind pen tester, I wouldn't necessarily think to pass in a parameter D, but by dumping out that application's attack surface, you could look at that and say, well, what does this parameter do? Let me fuzz that or send some, send some requests in that manipulate that. And then, maybe let's also go and look at the source codes so that we can find out why that stuff is there. And so you can potentially, again, by being able to quickly get some understanding of the application, how it's going to run, that can provide value both to the automated testing as well as, in this case, to manually looking and saying, that debug parameter, what is that doing? Let me include that in the scope of my testing. What you can also do by looking at the source code is look for potential MVC misconfiguration. So a lot of the MVC frameworks have auto binding, where they'll take the parameters that you pass in, according to some sequence, something dot something dot something, and it will stitch those to the object tree, that's running on the server side associated with a given session. And that's great from a convenience standpoint, but can also lead to a number of issues. Now, Dennis Cruz has done a lot of publication about this, other folks, about these types of issues. And so by looking at an application's configuration and by the parsing in the case of Spring, looking at the model, at the class dev model annotations and the properties associated there, what we're able to do is we're able to see, hey, for this given request, what are all the parameters that might be accepted? And that can help us identify potential issues on the server side. And so a great example of that is if we go up here, let's say we go to Pet Store. Here what we see is if you go and you look, you can identify the situations where you've got things like pet.birthdate, or you find longer ones here, owner.id.owner.pet.owner.firstname, right? And so we can identify, if I'm looking at that and saying, do I really want this URL to let me set things that far down in the object tree? And the answer may be yes, there's a good reason for that, or the answer may be no, there's not a great reason for that, and that's something that, that deserves further scrutiny. So just kind of in closing, I think we have a minute for questions after this before we roll over to the next talk. But look at a couple different things. The idea is, how can we use source code and source code analysis to help improve the quality of our dynamic testing, both improve the speed at which we can do it, as well as improve the coverage that we have. Again, this is something where I think that I think there's some interesting things that we've got that we can find right now, but there's other stuff that we can do as well. I think we've started to introduce the concepts of authentication and authorization, so that gets to be very interesting. Show me all the URLs that an unauthenticated user can access versus an authenticated user. If I have a set of static results, that may cause me to say, well, if I've got 1,000 cross-site scriptings, first I want to look at the 100 that you can access from an unauthenticated user. So we've started to introduce those concepts as well. And I think given the parsing that we're doing, to your question about Android, the things that we're doing to identify calls to certain method calls and things like that, those can be extended to look for additional method calls. And from that, we can do things like, hey, for this Android source code, show me whether or not it uses SQLite databases or files. So you can start to do some automation of threat model creation so you can understand here are the different things that this application touches. So that'll open up for if anybody has a question. And I'll be around later today and tomorrow. So, yes? So are you asking about data flow analysis? Uh-huh. Right. Yeah, and so the question is, are we doing any cross-function data flow analysis? No, we're not. And if you saw how, when we ran against the thread fix source code, which is 100,000 lines of code or something, it ran like that. We're not trying to replace a commercial grade static analysis engine, and so we're not doing that kind of cross method and any of that stuff. We do a little bit of intra method data flow analysis to identify some stuff, but really that's a different problem that I think those engines are solving, and we're really doing essentially kind of like a very, very close scoped semantic analysis. Again, using what we've built, could you extend that to start to do more data flow analysis? Potentially yes, but again, our mission was less to, we didn't set out to create a freely available commercial grade static analysis engine. Instead, we were trying to solve a different problem, which was how can I correlate the results of these commercial grade static and dynamic analysis engines? So what do we look for? Roots or functions? It depends on the language and the framework, but there's a lot for certain things. There's a lot of semantic analysis, looking for calls to things like get parameter, get headers, and things of that nature. Also parsing out, and I'm not a Ruby person, but parsing out the way that Ruby identifies parameters being identified, as well as doing things like parsing out Java annotations to look for, and Java Spring looking for controller and model and things of that nature. So it's a pretty fast. Tokenizing, it's a tokenizing parser, and then we just attach a couple of handlers to it, and so that's why it's super fast, because it lets us quickly identify those, and we've got little state machines that we run for that stuff. But again, it's not doing that kind of full data flow analysis where where it's cross method and things like that. So, excellent. Anything else? We great? Yes. Oh, right. I'm not running here, but and I forget the version number, but in earlier versions of SonarQube, each finding had to be associated with a file and a line of code, and so that made it harder and impossible. You would have to really do something weird to make SonarQube work with dynamic scan results. What we figured out is because we have that, given dynamic results and the endpoint database, we could map that back. So that let us map. We've got a SonarQube plugin as well that lets you take the results of dynamic testing and map those back to lines of code. One caveat is I think newer versions of SonarQube have relaxed or changed the requirement to have a specific file and line of code mapping for each finding that they're tracking. So we may have solved a problem that lived for like a week after we did it. But in any case, given that capability of taking a dynamic result, mapping it to a line of source code, another use we found for that was to map dynamic findings into SonarQube. Excellent. And that's all. Good. Well, thank you all very much.